Hello. I believe that in coming centuries humanity is going to spread out across the galaxy, and when that happens the transmission of messages is going to become key. At the moment on Earth it's sufficient to send messages by radio waves. We send a message up to a satellite and it bounces down, and that works very well because the distances are small.
Hello?
But that's not going to work in future. Consider the nearest star, Alpha Centauri, which is 4.2 light years away. That means it takes over 4 years for the light to get there. If we want to reply from there and we send it by radio waves, it's going to be nearly 9 years before we hear back. And I don't see how any civilization across the galaxy can exist if messages take that long. Therefore, the messages will have to go very much quicker than that. If we want to reply from Alpha Centauri within a week, then it turns out that the message will have to go 438 times faster than light travels. I call that 438 zips. If we want to get a reply from the centre of the galaxy, then average speed will have to be 4.3 billion zips. And if we want to get a reply from Andromeda galaxy during a lifetime, then the speed would need to be 1800 trillion zips. We've really got to start thinking in terms of incredibly fast spacecraft to take these messages about. Most people think that we won't be able to go that fast because nothing goes faster than light. I've argued before that actually the situation is nothing can be observed to go faster than light. I believe that Newton's third law, which is what powers spacecraft, that is, that every action has an equal and opposite reaction, as in this shotgun being fired, I believe that Newton's third law applies whatever the speed of a spacecraft as measured from Earth. So let's move to propulsion. We're going to need to think of something much better than these wonderful Saturn V rockets that took us to the moon. They were very good for a quick burst acceleration and getting us to the moon, but we need something much more powerful. I suggest that the region in which to look is Einstein's famous equation E = mc squared. And this number on the right here, the c squared, is so large that you only need a small amount of mass to produce an enormous amount of energy on the left-hand side. So perhaps we should draw the equation like this. I think this is the region in which to look. If we could find a way of turning a small amount of matter into energy, turning the whole of the matter into energy, that would be very powerful. At present, our nuclear processes only use the binding energy and not the entire substance of the mass. That would be very good. Then slowing these rockets down would be inefficient, uses more fuel. It would be much better to leave them running to crisscross the galaxy and to instead develop much better upload and download speeds. We've all waited for our computers. We don't want to be doing that in the future. We want a very quick download speed from a spacecraft moving fast past a port. Let's take the comparison of pipes. Consider this bath. If you had a large enough pipe, you could fill it in 1 second. This swimming pool is ridiculous to fill with a hose pipe. You need something much bigger, and imagine what you'd need to fill that with 1 second. Well, I think we're going to need the capacity, as it were, in terms of data transfer, the capacity to transfer all the oceans of the world up into orbit in 1 second. We need to think in those terms. So to conclude, the future is going to depend on very high, fast-moving spacecraft with good data transfer capability. And I believe the time to start thinking about these things is now. Thank you for your attention.